In this video, we're going to look at another example of how to solve a system of equations by using inverse matrices. So for this one, we have our system 7x plus 5y equals 3 and 3x minus 2y equals 22. Notice it's not set up as a matrix yet. And so our first step for this is going to be set up our matrix equation. Remember, the matrix equation consists of our coefficient matrix. So our coefficient matrix is 7, 3, and then 5, -2. And then we need to set up our variable matrix, which is our x and y as a column. And then set up our solution matrix of 3 and 22. So in this example, we had to create our matrix equation, coefficient matrix, variable matrix, and solution matrix. And then we have to remember to solve, you have to multiply both sides by the inverse. And so the next step would be to find the inverse. And so to find the inverse, you need to first get your determinant. And so my determinant, det, well, let's remember inverse is 1 over our determinant, where our a and d switch positions. You change the sign of b and you change the sign of c. So our determinant 7 times -2 is -14. And we're subtracting 3 times 5, which is 15. So our determinant is -29. So to find the inverse, we have 1 over -29 times the matrix, where a and d switch places. So -2 comes up here, 7 comes here. You change the sign of b, so +5 becomes -5. And change the sign of c, +3 becomes -3. And then perform your scalar multiplication. So 1 times -2 is -2, so -2 over -29 is a +2 over 29. -129 times -5 is +5 over 29. -129 times -3 is +3 over 29. And this would be -7 over 29. And so then there's our inverse matrix. And so the next step is to take that inverse matrix, and if you multiply it on the left side, remember, it gives you the identity matrix, so we don't need to show that. What we're going to do next is we are going to do front multiplication with our solution matrix. So we'll do front multiplication with the solution matrix. And so my variables coefficient, my variable matrix x, y is equal to my inverse matrix, because that goes in the front. So 2 over 29, 3 over 29, 5 over 29, and -7 over 29 times your solution matrix, which is 3 and 22. And then perform that operation. And so I have rows by columns. So I have 2 times 3 is 6, so 6 over 29 plus 5 times 22, which is 110 over 29. I have 3 times 3, which is 9 over 29. And then I have -7 times 22, so plus negative 154 over 29. And then just perform the operation. So 6 plus 110 is 116. So I have 116 over 29. And 9 minus plus a negative 154 is negative 145 over 29. Simplify. 116 divided by 29 is 4. And negative 145 divided by 29 is negative 5. And so x equals 4 and y equals negative 5. And so remember, the final step is to write your answer as an ordered pair. So write as a point. So you have the coordinate for negative 5 as your solution. So in this example, we had to create our coefficient matrix and variable matrix and solution matrix. We had to set up the matrix equation. But then we, again, same as we did in the previous video, find our inverse and do front multiplication with it. Form the multiplication, simplify, get our x's and y's, and write it as an ordered pair. Now, in the final video, the next video, I'm not going to go through and label each of these steps for it. I'm just going to go through and attempt the problem from beginning to end. So my advice is to make sure you are comfortable with this process on how to solve a system of equations prior to looking at example number 3.